Good afternoon to everyone. Thank you very much for joining our guest lecture. Uh, we have Mr. Vigesh Sivakumar. He is a senior cloud consultant. He have a very good experience in cloud application, and he have built quite a number of projects. And he have certified in Google Cloud related certification. And he have vast experience in building a DevOps application. Finally, I will say he's my ex-student, very good student that time. Now he is performing very well in the industry. So he will be sharing with us his experience on a mobile DevOps pipeline and some more trending area in DevOps. And finally, we will be having some demo from Mr. Vigesh. Okay, so with that, I will hand over to Mr. Vigesh. Mr. Vigesh Sivakumar. These are our my module student. Thank you, Mr. Vigesh.
Hey,
I hand over to you.
Hey, hi. Thank you very much. Hi, everyone. Good afternoon. So, hope you all are doing well, and then your family is all fine with this pandemic situations. Yeah, let's make this as an interactive session so that everyone can learn each other, and then you can get expertised in the field as well. Okay, so let's start. Let's start it. So today we are going to see, we learn what is DevOps first of all, and then we will see how we can able to implement DevOps into the real-time project, and also we will learn about mobile DevOps. I mean, into mobile application, how the DevOps is being utilized, and also at the final we will also have a small demo, like how we can able to implement a DevOps pipeline for the mobile application development. So the demo will be very short, so I cannot give you the full entire pipeline for a complete application. So today's agenda, we will be talking about DevOps and what is DevOps and why the DevOps is being implemented, and then why it is getting popular. And also we will see about the DevOps lifecycle and then the tools that being used in the market. And we will also look out mobile platform and how the development approach is being carried on. And then we will learn the new tools, Flutter and Firebase. If you have already not been, if you have not already heard about, I will explain that. And then we will see a DevOps implementation, basically the architecture, what we are going to implement on the demo. And then we will have a demo on Google Cloud. So this will be the today's agenda. So let's start. Yeah. So what is DevOps? So if you have already known, so DevOps is like on the internet you can find lot of, if you Google it, what is DevOps, you will find a lot of information about DevOps. Like each and everyone will talk about DevOps in a different way, but fortunately or unfortunately all of them are correct only. But if you get to know, like DevOps is apart from being a buzzword on the internet or a trending role in the market, DevOps is a compound of two words, basically development and operations. So that is called DevOps. So basically nothing but development teams and operations teams are going to join together, and then they are going to implement the solutions. So that is what DevOps means. So I will talk about the development, what is the development team is going to do, and then operation team is going to do in the later session. Before understanding what is the problem statement that the exact problem is DevOps is trying to solve, we will first of all learn what is DevOps first. So DevOps is not a tool, it's not a software or not a programming language or a framework. So it is a practice that combines both software development and then the IT operations. So IT operations means like a software developer will design code that application or design the application, but it has to be hosted someplace. So that is what the operations team will do. So it's a practice between both of the team, and then they collaborate each other. And basically the DevOps makes the operation team and the IT team to collaborate each other and then give more productivity and automate whichever the things that they wanted to do. So that is what DevOps. So DevOps is not a tool or a software. It is a practice, or it is an collaboration thing. It's not a tool or a software. So that is what DevOps means. So what does a DevOps helps actually? So it helps to reduce the life cycle of software development. As you already know, like software development life cycle, like where it starts from coding and then planning coding and then till the launch of the applications. So there are a lot of steps in order to launch one particular product. So that is what the DevOps is making is the life easier to launch an application, and then basically it bridges the gap between the teams. So like if you have already seen that in a company like there will be a development team where it develops the application, but finally if you package the application and then you give it to the person who hosts it on the internet or host it on a server, then he may come back and then saying that, hey, the package that you have sent, it's not working. So because your environment, you are working on a Mac, or maybe the person who is hosting on the internet or the server is using Windows. So there are different scenarios. It can break up your program that you have developed. If you are a small company, you develop by yourself, and then you host by yourself, you won't face this issue. If you go to like enterprise companies like Lazada, Facebook, WhatsApp, Grab, YouTube, all those companies, right? So there are like thousands of people are working for that. So in that way, like if you see like one programmer work in morning shift and then another programmer work in night shift, and then each of them will not have a connectivity at all, but all of them are doing the same task and then the same module. Then finally the module has to be hosted to the internet or to the public on a server. So when you finish programmer 1 does the programming for one module, and then program 2 does for the second module, and then someone has to be merged it, and then it has to be hosted on a server. So it has a lot of struggles. Like if you see, like there will be a blame that from DevOps team, that a development team saying that, hey, I have done all the things, but if you're facing an issue, I have a proof that it's all been working. But the operations team may say, yeah, your environment is not working on my environment. So there will be a blames, is there, right? So, and also the release cycle. For example, you develop a module, and then in order to launch that release, it may take a month, because you are going to take an application, develop it, and then host it on a server. So it may it is a production application. So a lot of people are using it. So you cannot daily host the application, and then it may break up the application itself, and then there will be a downtime. So that means, let's say, for example, if you go to Google and then it says that it's not working, so the customers will face, okay, so this is not a good product. So they will jump for the other product. So in order to stop that, we need to have a release cycle very easy and constant, and then the people, the users who are using the product has to have a what is that called? They should not feel that this product is not good. So in order to keep up the users, we need to have the application running very smooth, and we have to have a constant release life cycle. So that, like, in order to release one module, we should not wait for 1 month till the release date to launch it. So it should be continuous. So that is what the DevOps is going to fill up the gap. And also the competitor. So let's say, for example, today some technology released. Let's say, example, WhatsApp released a shopping module on WhatsApp. So the other e-commerce competitors, they have to come up with an API which it can able to tackle this technology. So if you are doing slowly, and then you develop it, and then you wait for the life cycle. I mean, you wait for the release date to launch it. Then competitor may already launched it because he has a DevOps implemented, and then his life cycle is very short. Like every day he can launch the new application. So these are the gaps that it bridges the. DevOps bridges it. So let's take a life cycle. Let's look at a life cycle. So this is how the typical DevOps life cycle will look like. I will explain one by one. So the stage where it comes, starting stage will be plan. So whenever you want to design an application, first of all, you will have a plan. First of all, what you wanted to design. I mean, what you want to put in a product. Like what are the features has to be inside the product. So these and all comes under a plan stage. So for that, you can use Jira or you can use Redmine. Redmine, so Jira is a paid version, and then if your company is not capable of investing into small tools, then you can go for open source like Redmine. So these are Trello. There are a lot of tools for that. It depends on whichever the one that you are convenient. The people will start using it. So on this stage, basically we will plan everything. What are the features it has to be, what are the features it is going to have, and then what are the features, what are the steps actually, and each feature, what modules we are going to launch. Everything will come under plan. Let's say, for example, you planned everything. Okay, you have without DevOps. Let's assume without DevOps. You planned everything, and then you developed everything, and then you released the product. While releasing the product, market already, the current market already out of date. So you need to include some other features inside the product. Then what you need to do, you need to go down again and then start from planning and then developing. So this is a long life cycle. So when you follow a DevOps, it continuous kind of continuous integration and development. So that is what DevOps means. So we plan. And then after planning, we will give it to a programmer where we used to code the modules and everything that he has developed. And then in order to solve the problem between multiple teams and multiple programmers, you need kind of a version control. So that is where the Git and source code repository or Jira or many like Bitbucket, there are a lot of version control systems is there. So basically that helps, like, let's say, for example, there is a development team working in India, and then there is a development team working in Malaysia. So the time zone is different, and then each one will be working on different modules. So how do you merge each of the code that they are working? So there should be, so let's say, for example, the same person on Malaysia is working on same module, and then the different person working on the same module in India. So there will be a conflict, right? So that is where the Git and the source code repository bridges the gap between the teams. So now the next stage is build. So now we have already planned, and then we build the code. We programmed the code, and then we developed the code. And the next stage is to build that code, basically. So after building it, like there are a lot of tools like Maven, Grid. So based on the technology that you use, like PHP, Java, Python, whichever the programming language you use. So based on that, there are packages, or there are modules for building that. So building that is nothing but you're packaging whatever that you did the code. Let's say, for example, in a simple use case, you developed an application, but you need to launch it, right? Like either you need to make it as an exe, or you need to make it like for example, in mobile app, you need to make it as an APK. So that is what the build thing happens. So after build it, you have to test it, right? So that is where the test phase comes in. So for test, based on the technology that you use, the like Selenium is that, JUnit is that. These are some of the examples I just posted. So on this phase, basically you test the application, whatever you did, and then if there is any flaws, then you put it back to programmer, and then they fix it, then they build it, and then they come back to test it. So now we have done planning, we have the build, we have programmed the code, we have built the code, and then we have tested it. Now the next stage is to publish launch the application that you have developed. So that is where the release cycle comes in. So in order for that, we can use Jenkins, we can use Spinnaker. So these kind of an CI/CD tools that you can able to release it automatically. So if you don't understand this cycle, I will show you while I'm showing a demo, you will completely understand what is this life cycle is about. So now we have launched it and then we have released it, and then we need to deploy it somewhere, right? So deploy it in a server or deploy it in a Play Store or App Store. It has to be deployed somewhere in order to get a traffic from the public. So the deployment phase comes in. So for that, you can use Terraform or you can use JFansible. So there are a lot of deployment tools are there in the market. But when you come into automations on like Terraform is more better in compared to other tools. So now we deployed it. So customers have started using it. So then you have to operate and monitor, right? So let's say, for example, customer is facing some problem or your program itself facing some package issue. So that is where the operate and monitor comes into the picture. So you operate it and then you monitor the application that you have launched. So you can use Splunk to check out the logs, and then you can use Nagios to monitor the traffic of the application. And then let's say, for example, you launched an application and then you launched an application on one particular region, let's say, for example, Malaysia, and then you created one particular server on cloud, and then you have launched it. So your application become popular. So then the traffic increases a lot. So one server will not able to tackle your request. Basically, the traffic comes into the application. So basically, you need to monitor that application using Nagios or some other open source, like open source. There are a lot of open source. Nagios itself is an open source. Then you can auto scale your servers. Like there are a lot of like if you come into cloud, there are a lot of new technologies now to auto scale automatically based on the traffic, and then based on the percentage, or you can schedule how. Let's say, for example, today you are going to launch some event. So whenever there is an event comes in, there will be a lot of traffic. So we can schedule schedule the server to increase more RAMs and more CPUs, then so that your customer will not face lagging. So this is the complete life cycle of a DevOps. It looks like it's a typical life cycle pattern, but there are a lot of tools. I'm just put like few tools, popular tools that recently in the market they are using. So this is what DevOps means. So I hope everyone has understand what is DevOps. Okay, so now we learned what is DevOps. So now let's come into the picture where the mobile DevOps comes in. So now we know what is DevOps and what are the tools we use, what is the life cycle of it. So now let's come into a war and love. So in the market, if you in the right now, when you see there is only two players, either Android or iOS. So when you come into mobile platform, those are the main players right now. So if you are building some application, example, if you are building an application, you need to either build for Android separately, and then you need to build for iOS separately. So then you have to maintain two development teams, you have to maintain two infrastructure, you have to maintain two release cycle. So basically, it comes a long pattern in order to launch one application in the market right now, because you have different users and different market. So now right now let's see the architecture of each one. So this is the approach of building a mobile application basically. So there are two streams in mobile application development. Either is a single platform or cross platform. So single platform means you build the app specifically for Android or specifically for iOS. So that is where single platform means. So you only build for that particular app. Single platform means nothing but you specifically build app for specific application like Android or iOS, whichever. So cross-platform means there are two types of cross-platform, where you build an hybrid app and then where you build a web app. So hybrid app is nothing but it acts like an native application, but it supports both Android and iOS. So that is what the advantage. So the native app, you have to build separate apps for each platform like Android and iOS. And but hybrid app, you can build single code. You can have a single code base, and then you can have both for Android and iOS. And then there is a new technology called web app. So web app is not for you cannot use for all the scenarios that currently in the market, but those are for like very basic applications like viewing or blogging. So those applications and all, you can use it on a web app. So these are the approaches, current approaches for the building an app actually. So now we seen what are the development approaches. So now let's see the architecture of each and how it looks like. So this is the native approach architecture. So native approach architecture is nothing but you build an application on top of Kotlin or Java or Swift. So like Kotlin is for Android and then Swift is for Mac, I mean iOS. Then you can build an application. Then the application will talk to OEM widget that is inside the device. The device will talk to the canvas and events, and nothing but the communication between from the user whenever he clicks on a button, and then it goes to the hardware OEM, and then it gives a request to the event, and then it accesses the services. So that is how the native application will work. So that is why we are building a separate application for each thing. So now let's see for hybrid application. So hybrid application, it's also it gives you one bridge so that you can develop one application and then you can host it on both. So you develop one program in either there are a lot of tools for that. I will explain the next step. So like JavaScript, you can use a JavaScript, and then there is a bridge between that. That's where the hybrid approach comes into the picture, and then it connects to the hardware services. So you develop one source code, and then it can be used for both Android and iOS. So that is what hybrid app. So these are, so like if you see here, so these are the technologies that I have listed, like Ionic is there, and then Cordova is there, and then React, Flutter, Angular, Polymer. So these are the tools that currently in the market, currently highly used in the market for developing the applications. So now we know both what is native application and then what is hybrid application. So now let's come into the picture. So Flutter. So I hope some of you already been known about this technology. So Flutter is recently getting very popular on hybrid application development. And then I will tell you what is the reason it is getting more familiar when it come into hybrid application. And then if you see, like, Flutter is an open source project. That is one good thing. And then it is developed by Google, and then it is used for cross-platform applications, like as I said. So we have seen before, like cross-platform basically supports only Android and iOS, right? But Flutter, if you see, it supports for all the platforms that are currently in the market, like iOS, Linux, Map application, Windows application, Fuchsia, that is the new OS Google is going to launch. And then so all these operating system, a single platform will support. So let's say, for example, you are building an e-commerce website, or maybe you're building some applications like TikTok or WhatsApp, whichever the applications. So when you come up with some new idea and then you build the application, then while you are planning it, you have to plan for building for different operating system like Android, iOS, Linux, Mac. There are a lot of new operating system coming up. So when you start a product, you have to think of all those things. So that is where the Flutter helps you as a single tool or a single code base. You can develop a program that supports all the platform. So that is where the Flutter helps you. So it helps rapid development, and then it have a beautiful UI with material design. If you heard about material designing in the front end, and then it look exactly like the native app, and then the speed and performance is equal to the native app, how you get it. So that is what the Flutter means. So that is how the Flutter is being developed. So how this Flutter is so unique, because it has the native code directly talking to talking to the widgets. So previously we've seen, let's say, let me go back one step. So previously we've seen the JavaScript is talking to the bridge, and then the bridge is talking to the services. So there is somewhere gap in between in order to, so that's how the bridge is being filled, right? So let's look into the Flutter approach. So Flutter, it has a bridge. So what they have done, instead of so whenever they wanted to talk to the physical services like location, Bluetooth, camera, then only it uses the bridge. Otherwise, what they bring up is they move the widgets itself from the hardware perspective to the native code perspective. So if you see this architecture, so the widget is over here. So the application has to talk to the widget on the hardware, and then it reverses back the response. But if you see the Flutter approach, they brought the widget itself into the application native code, and then it talks very directly into the services. So that's how the Flutter is being. That's how the Flutter is getting popular. And then there is no bridge basically. So Flutter is developed on top of Dart language. So Dart is really new technology that have a capability of doing a lot of things. So Dart is a really upcoming programming language that every market will going to use soon. So now we have seen that. So now we know to in order to design the front end of an application, we can use Flutter. So there are other applications as well, like as I mentioned here. So we can use React, we can use Cordova. So there are a lot other tools as well. But Flutter is recently getting more familiar in the market. But when you see like within 1-2 years, Flutter will be very popular. So that is why I'm saying Flutter is one as a tool that can be used for building the front end UI. So now we build the UI, and then we understand the architecture of how Flutter works. So now let's go into backend. So we have an UI, we designed the UI. Some UI has to be communicated to some other backend in order to fetch the data. So that is why the Firebase comes into the picture. So Firebase is also Google's product. It's mainly built for mobile application approach development. So like you can build the application very faster, and then the release cycle can be easier, and then you can monitor the application, and then you can monitor the backend on the Firebase itself. And then engagement is nothing but you launched a product. How good is the product is performing in the market? Who are the users are downloading? What are the modules that are they using? Like what is the traffic? So all this you can able to easily monitor using the Firebase. So Firebase is nothing but it's a backend platform for mobile applications. You can also use for front end, but it's for a hosting only. It's not like you can release an app itself from there. It's kind of a middleman. You design a front end, and then you connect to a backend, and then you can use it. One advantage is that Firebase can be used for real-time purpose, for chatting and maybe like ordering systems and all those, because it has a real-time capability where it like really very fast real sync. So you logged in and also it has an advantage of authentication. So Firebase itself has a backend that connects to all the APIs like Google, like you. If you open an application, you used to have like sign in using Google, sign in using Facebook. So these and all, it's already pre-built. So what we need to do is just connect to that API. That's all. So it's already been there. So and then it also connects to the database. And one good advantage is that since the Firebase is built by Google, you have a lot of advantages of using the backend as well. So backend in a sense that I'm saying that servers. Let me talk about that in a picture. So see here, if you see here, so these are the features that you get when you start using Firebase. So since you build a product, you launched it on a Firebase. So you're not going to stop that. You have to keep on growing that application in order to keep up in the market. So in order to keep up in the market, you need to have like artificial intelligence, ML, machine learning kind of stuff. You need to have analyticals. You need to have some kind of machine learning, program learning in. So these capabilities, Firebase easily connects to the Google Cloud, because it has a Firebase is built by Google, and then it can be connected to the Google Cloud as well. Like if you see, there are cloud functions, there are cloud Firestore. So these cloud functions is nothing but serverless architecture. So let's say, for example, you wanted to reduce the cost of hosting a server. Like server is like, if you rent a server, your server will cost like $120 per month. But you don't have a budget. Then you can go for a cloud function. You build a cloud function, you host it on a Google Cloud. Whenever a request comes, then you pay for it. If there is no request, you don't pay for it. So server is maintained by Google. You don't need to maintain anything. So when a traffic comes, you pay for the traffic. If you don't have any traffic, you don't need to pay. So that's how it's. So serverless is a new technology that are doing a lot in the market right now. So that is a different stream. But cloud function is one of the good advantage of using it. So this is what Firebase means. So now we seen front end, and then we seen back end, what we can use. Okay. So let me tell you some of the popular apps built on top of Flutter. So if you see AliExpress. So AliExpress recently, they completely migrated from their native approach to Flutter. So the huge giant already been moved to Flutter. Why? Because he knows that moving forward, the operating system, there will be a lot of operating system. So in order to tackle with those different operating system, he cannot have like thousands of people working for him just for developing one application, and then different teams. So they have decided at a good point, and then taken a good decision. They have been revamped the whole entire AliExpress into Flutter development. And then if you also you can take WeChat. So WeChat, when they start the company, they were doing native application development. So they have different team for Android, different team for iOS. Then they develop the application for both. So if you see, like even some Android will have some additional feature, but iOS will not have additional feature, because the time to develop for each operating system will take time. So that is why they did a good decision, and then they moved to Flutter. So now the WeChat is running on top of Flutter. Not only this, like if you go to any products like Google Assistants or Google Pay, or even the Google the mobile app, the app itself. So everything is top of Flutter. So everybody is using the application, but they don't know which technology is behind it. So when you come into technology field, then you know who are the giant players inside the market. So now we learned what is Flutter. Now we also learned what is Firebase. So now the next step is to understand how the DevOps can be implemented with this scenario. So I will take Firebase. So since I don't have much time, so I cannot create an UI using Flutter. So what I will do, I will take a Firebase, and then I will implement a DevOps lifecycle on top of Firebase. So what we will be doing, let's see. Is there any doubt? First of all?
Okay, guys, if you have any question, you can ask from the point of the theory part that he explained. If you have anything, you can ask. If you don't have at the moment, you can keep it for the end of the session. Thank you. I think we go for a demo, Mr. Vigesh. After that, if they have, we will attend at the end.
Okay.
Thank you.
So let's come into architecture. So you before you're doing something, right? So you need to plan it, right? So that is where the architecture helps it. So you need to implement a DevOps. So to implement a DevOps, you need to assume a plan, first of all, how I am going to implement a DevOps. So let me give you an overview what we are going to see in a demo first, and then I will explain how this architecture works. So we are going to do both ways. Okay. So we are going to do in both ways. Let me come back to that. So we are going to create a pipeline for deploying a website based on Hugo. So Hugo is nothing but is a static website builder. You don't need to do program. You don't need to do programming. You can use the website is already pre-built by kind of a themes. You can host it, and then you can just change the content whatever that you wanted to change. So that's what Hugo means. So Hugo is a static website builder. So in this demo, what we are going to do, we are going to see the approach in two ways, by traditional and then the modern way of implementing through DevOps. Traditional meaning we will be creating I have already created a server, so just to reduce the time. So we will be downloading the Hugo package, and then we will be installing the necessary softwares for that, and then we will install the Hugo itself, and then we will download a theme, and then we will customize the theme, and then we will launch it in a cloud. So that is how the traditional works. So if I follow the traditional way, if you are non-experienced, it may take for you half an hour to 1 hour. So since I'm a little bit expertised with that, for me it will take like 15 to 20 minutes. But when it comes into modern way of DevOps, what I don't need to do anything. Just 2 minutes, I can launch an application. I can show you that in live itself. Within 2 minutes, the entire DevOps lifecycle will run, and then it will launch the application on cloud. So that is what we are going to see a demo on the DevOps. So now let's come back to architecture. So the development teams, they are developing the program. So like I'm going to install download the program, download the package and do a small changes in the program, and then I'm going to save that into a code repository. Code repository is nothing but source code management. It's code repository is a Google build tool. It like Git and GitHub and Jira, there are a lot of tools for source code. So I'm using code repository because I'm expertise with Google. So I'm going to use code repository, and then I will commit the code into that, and then I will trigger a pipeline. So pipeline is nothing but the DevOps. So the trigger a pipeline using cloud build. So cloud build is nothing but it is an CI/CD tool where you can able to automate like continuous integration, continuous testing, and continuous deployment. So all these three are already in cloud build. So I'm going to use that tool for this demo. And then what I'm going to do in that cloud build, basically the manual thing that I'm doing, right? I'm downloading the Hugo and then installing the Hugo and then doing some changes and then deploying it. And then I'm going to host it on a Firebase in order to get the traffic from the internet. So that is what we are going to see a demo. Okay. So now let's go to demo. Let me stop sharing it and then I will bring another screen.
Really very much for sharing your experience and knowledge in this. I really wish you all the best for the next chapter in your career. I know you're looking forward to that. Okay, guys, if you have any question, you can ask. And Mr. Vigesh already shared his LinkedIn profile. You can see his profile, and then you can connect with him. And sure, you will be learning lots of things from him. Even I am learning from him. He is my mentor now on the Google Cloud. Okay, guys, if you have anything at the last one time, you can ask. If not, thank you very much for everyone. Thank you, Mr. Vigesh.
Thank you so much, everyone. Thank you.
Thank you.
So